I am very thankful to you for it, inviting me for a talk on this Indian tradition of mathematics. Let us, this is a very vast, big topic, but I take this as a introductory presentation of the topic. As we know, India, that is Bharat contribution in the world of knowledge covers all branches of knowledge. From the Vedic period onwards, all this knowledge system was developed. But during the Vedic period itself, the branches was divided into six Vedankas. In these six Vedankas, mathematics or the content of mathematics was named Jyotisha or Jyotishastra. Vedanta Jyotisha, we are famous with this word. And the science of Jyotisha or Jyotishastra or mathematics, it is given high respect in 1200 BCE, that is before Common Era. Lakada compiled the book Vedanta Jyotisha. In his Vedanta Jyotisha, he says the importance of mathematics in these four lines. Yada Shikha Mayogana Naganam Manayo Tada Tad Vedanga Shastranam Ganidam Murdani Sthiti. Like the Shika of Mayugas, of peacock, crest of peacock. It is like a crest of peacocks. And it is like the Manikya, that means the pearl at the head of a serpent. There is a belief that there is a very precious stone or pearls on the head of serpents, not snakes. And in that way, in all branches of knowledge, in all the Vedanta Shastranam, Ganidam, Murdhani Sthiti, it is the highest in the all among all the branches of Vedic knowledge or science. Only in the 19th century, the importance of mathematics was realized in the West, I mean the Europe, and they told mathematics is the queen of all sciences. But years back, centuries back, millenniums back, India, our Hirshis, has recognized the importance of mathematics. And mathematics was not treated as a different subject. Now, what happened to the study of mathematics? Mathematics is taken from all the real situations, and we are teaching and we are learning mathematics as a separate watertight something, so a knowledge system. So the mathematics was with Jyotishastra, mathematics was with architecture, mathematics was with this in nowadays we can say pharmaceutical, that is preparation of medicines, preparation of paints, preparation of many things. So everywhere the content or the subject was mathematics, and for mathematics there was another name for mathematics, that was Yukti Bhasha, the language of reasoning. Nowadays, many people, many mathematicians, many educationists says, if we put a question, what is mathematics? They will say it is a language of reasoning. But the same thing was told by our great persons years back. So in this 1 hour talk, I'm not taking the whole panorama of Indian mathematics that we know, but a small uh, geographical area that is Kerala. Now we are calling Kerala, but it's a very small area even in Kerala. How the mathematics tradition was flourished, what are their unique contribution into the world of mathematics, and how it was a continuous Nirantaram. There was no break at all. Break means in very old history, we can't identify all the people, but in the last 3 4 centuries, we can identify one by one lineage, Guru Shishya Parampara, in this mathematical tradition. In that way, K.V. Sharma, Dr. K.V. Sharma, who was a great scientist in mathematics as well as a veracious, um, not researcher, but he was inquiring on palm leaves and metal leaves on Indian manuscript. Was basically the manuscript department HOD of Madras University, and he worked even in Osiapur University in Punjab. With that positions, he has wandered over Kerala, South India, especially Tamil Nadu, Kerala, Andhra, and Karnataka, and he collected the palm leaves in which these manuscripts were made. And in Madras, Adayar University, Adayar Center, and Kerala, Cochin Tripunithura, and Kerala University, Trivandrum, there are huge collection of families' manuscript which is unexplored. Um, explored. So these are some of the lights that he has given to us. And in today's in general discussion, those who are discussing on Kerala School of Mathematics, they start from Sangama Grama Madhava of 14th century. But that we can say Madhava school, but Kerala school starts years back. The uh, if we scientifically go back, we can trace this lineage from Vararuchi. Vararuchi is famous in Indian mythology and Aidihyas. He was considered as a pearl Navaratnas among Navaratnas of Vikramaditya. And in Indian history, we can see so many Varadujis. Some Varadujis are grammarians, some are medical practitioners, some other uniqueness. But this Varaduji, which in even in Kerala there is a traditional um, mythology of Parai Petta Pandirugulam. That means a lady who is considered as a outcasted lady had 12 son, sons, not sons. One is a daughter, children, and his husband is a great scholar Vararuji. A great scholar Vararuji married a lower caste woman that she belongs to Paraya community, and they had 12 children, and the first one was a Brahmin Nambudiri boy, and he is considered as the father of Vedic tradition of Kerala. Their family tradition is still there, and when he lighted the first yaga Agni in the yaga, it is mentioned, and they are continuously that family is observing and maintaining that tradition with all reverence today also, and that family is called Mejatur Agnihotri's family. That family is still at Palakkad district of today, very near to Palakkad, and very near to Kunnankulam, which is very famous place in Thrissur, entry of Thrissur. And he is believed that he was a 4th century of AD, common era, because this family are maintaining their records when they conducted a yagakni at different yagas. The lineage they are maintaining today, and with that materials, we can assume that the timing of Varadoji, this Varadoji, a mathematician, and he was also a grammarian also, was 4th century. The main important contribution of Varadoji is two things. One is a new system of numerical representation. In Vedic system or Indian system, we had two type of numerals. One is numerals by 1, 2, 3 with the different numerals we had, and the other one was words for sankyas. It is called Buddha Sankhya system. The word that may be representing a number. For example, we have Trimurti. So if we use Trimurti, it is three. And like Nayanam, I, it is two. Shiva, it is one. So with the word which connect with some numbers, it is told like, so nakshatra means 27. In that way, many type this type of representation, word representation, instead of number they use the word, it is called Buddha Sankhya. And Varaduji's contribution was, instead of these words for numbers, he introduced letters for numbers. And this is called Katabayadi. That is Ka to 10 digits, then Da, Ka, Da, Pa, Ya. Adi means like this. And all vowels have no number and zeros. In this way, he introduced a new system of numbers. This is called Katabayadi system, and it is a very creative presentation of mathematics with poems, with different codings. This is a type of coding. And another thing is his Chandravakyas. Chandravakyas was the basic concept of finding out the position of all the planets. So, based on Chandra's position, that moon's position at a particular day, they can find out the position of all other planets. So, 248 Chandravakyas was created by this Vararuji, and he gave this in a way of poem with Katapaya, the way of numeration. And the next person we may be knowing, and this is little dispute is the Aryabhata. We can't say where he took birth. Only Aryabhata mentions in his Aryabhatiyam that he is a Kusumapura Vasi. Kusumapura Vasi means he was residing at Kusumapuram. Kusumapuram is the near place of Pataliputram, that is today's Patna, and he was the mathematics professor in Nalanda University, and we believe that he assumed the Kulpadi or the vice chancellor of that university for a long time. And in Aryabhata, he says he is giving the knowledge system which is prevalent in Kusumapura or in that area. And there was different opinion about his birthplace, all these things. His direct disciple and his commentator was Bhaskara and Brahmagupta. They told he was Ashmaga Deshi. Ashmaga Deshi, according to the Jain belief, Bharata Varsha was two parts. One is Ayodhya, the Uttar Bharata. The other was Ashmaga, that is the Dakshina Bharata. He belongs to Dakshina Bharata, and the Kendra center of Ashmaga was now the present day Shravana Balahola of Karnataka near Mysore, and that was a big giant center that we know. The giant Bahubali's biggest single stone statue is there, and this all South India were considered as Ashmaga. And there was some argument that Ashmaga means stone. So Ashmaga place is Kodungallur. That is a place very near to in between Cochin and Trichy. But that was not accepted by any, not any. Many of the historians recently, another scientist, especially uh, is a basically modern astronomer. He is a physics PhD professor and working in ONGC. He used with the modern techniques of software, that is Pentium or Stellarium, like many softwares are there for the analysis of planetary motions. With this, he observed that many of the observations that Aryabhatta put in his Aryabhatiyam, he had their observation from South India, especially near Calicut, that is very near to this Bharatapuzha's sea face. The importance of that place is in ancient India, the zero meridian was considered as Ujjain Rekha. That means the meridian passing through Ujjain. If we draw the same meridian nowadays, that meridian touches the sea. The seafood is near Malabar. So this scholar says he came to that point and observed from there, and he closed towards south along the sea shore, and he observed many of the celestial observation from the South India, and mainly the Aryabhata schools were very much flourished in Kerala, South India. So there is a demand that not from his birthplace, but he was the greatest um, guru. He is considered as the guru of Kerala School of Mathematics. Then comes after he was in we know that he was in 15th century, 5th century. He's mentioned his time, his birth, all these in his Aryabhatiya. Then comes Haridatta. Haridatta belonged to 6th century. In the earliest stage, we can identify one great mathematician in one century. There may be a series of mathematicians, but we couldn't identify all the persons. When there was a correction in the previous mathematician's observation, a new era, new approach was started. So then comes Haridatta after 200 years of Aryabhata's mathematical calculation. He find out that the observation values and the calculated value according to Aryabhata shows some differences in the actual place of grahas, the planets. And he corrected this one, and it is called Parahida Ganidam. Parahida means it is for the benefit of others. And his observations were he presented in Mamangam. That was a big gathering of all type of people like our Kumbh Mela, Dakshina Kumbh Mela. There was Vidul Sabhas on Vedic science, on this Jyotisha, on trade and commerce. All these things were there. I think you had a talk on this Mamanka also. And in the Mangmamba held in 683 CE, he presented his observations, what are the corrections, and the Vidul Sabha, the scholars' bench was accepted, and this Parahida Ganida system was accepted as the basis of calculation. And this was a great contribution that how Indians believed. Indians were always critic to everything, and they never swallowed anything. Even the great persons like Aryabhata, what he gave, there was continuous observation and rectification of the result. When they found that there was an error, they worked on that and find out a solution and correction process. This is called Parahida Ganida. Thereafter, in the ninth century comes Govinda Swami. That time Kerala had a good administrative system also under Sheraman Perumal's or the Kulashekara kingdoms based at Mahodeyapuram, which is Kodungalur, very near to Kochi and Trichur. And there he was considered as the Asthana Jyotishi, the Jyotishi of the palace. And his main contribution there was for all these calculations, as we know, we want the trigonometric ratios. So the trigonometric ratios was in a big intervals. Then he introduced in modern names we can say interpolation. It is called Andarganana system, Siddhanta. Andargana means in the interval they will break the interval to decimal intervals, small intervals, and they will find out the mean values of the intervals. This is nowadays it is called in mathematics interpolation, and he um, rectified the both Aryabhata's as well as Haridatta's sign tables, and he gave minute wise position or value of sign table. And as we know, this is the starting of mathematical analysis. Mathematical analysis start as a um, even in the finite space, the interpolation is the mathematical analysis beginning. And thereafter is direct disciple Shankara Narayana comes. Shankara Narayana's main contribution is that in Mahodayapura he established an observatory. It is called Nakshatra Bangla. In Delhi we have Jantar Mandir of 18th, 17th century something, Mansings. But even before that, in the 10th century, Shankara Narayana established observatory in Kodungalur, that is Mahodayapura, and he had two main books. One is the Vyakhyana of Lapu Bhaskariya. It is called Vivarana Al and Shankara Narayaniyam. Two things. The main relevance of this book is It is a source book of Kerala's ancient history because in this he gives the chronological system or order of all the Kerala, Kulashekaras and Chera Chola kingdoms, and he was a Jyotishi, Jyotisha Vidwan of that palace, and that time's king Stanu Ravi Varma was a famous mathematician or Jyotishi, and both they have different dialogues on Jyotisha, Jyotishastra, and mathematics. In that way, Shankara Narayana's contribution is one the observatory mathematics and giving an establishing an observatory, and they introduced a clock tower also. There was a system of um, giving bells in a particular interval of time, and that was a very big contribution in the area of timing and observatory mathematics. Then comes a different type of mathematician. One is Talakkadattu Govinda Bhattatiri. He belongs to 12th and 13th century. That time he had made a big Vyakhyanam to Varahamihira's Brihad Jadagam. And Varahamihira's Brihad Jadagam, it has 23 chapters, but he took 10 chapters and he corrected it and elaborately presented it, which is called the Dashadhyayi, Dasha Adhyayi, 10 chapters, and this became the basic test of Jyotisha, which is considered even as the basic test today. And he has so many other experience, many the modern tradition of astrologers. They start from Talakkadat Govinda Bhattatiri and his genius. This Jyotisha, which have two parts, that is, one is mathematics part, the other is foretelling. And there was a shift from mathematics part to a Jyotisha part, that is foretelling part. And there also, when the calculations was went wrong, he went for a tirthana, not tirthana, he went away from his village and he find out a guru in Tamil Nadu in Pandya. From there he learned more on astronomy and he got a mantra diksha that the guru told him not only the mere mathematics, you should have a sadhana and your ishta devadas varam that you should get. Then only the prediction will be correct. Like that, they even today the South Indian people follows this system of Talakkadattu Govinda Bhattatirim and mainly his book on Deshadhyayi and then Muhurta Ratna and another one is Mahabhaskarya's Vyakhyanam. These are very famous. Then comes our great mathematician of 13th and 14th century, Sankama Grama Madhava. We can connect Madhava to Tadakkadattu Bhattatiri or any other, but this place is very near to Kodungalur, only 12 kilometer away from Kodungalur. He may be a product of Kodungalur Gurukula. We can't trace the direct lineage, but their family is still there, very near to Iringala Kuda railway station. Iringala Kuda was known as Sankama Gramam earlier. There is Sankameshwara Kshetra of Bharada, that is Sri Rama's brother Bharada's big temple is there. And Sangama Grama means two rivers. They bifurcated one at one place and they again joined. This is the geographical area like an island. It is not an island, but there are two rivers, but they come like this and go away, divert, then again come and join together. So in this area is called Sankama Gramam in the medieval period. It is one municipality and two, three panchayat, and there this great mathematician of modern era starts, and his main contribution is, as we know, he jumped or took the mathematics from finite analysis to infinite analysis. It is called in Sanskrit parimeya to aparimeya. He dealt with all um, infinite series. For every value correction, he introduced a infinite series. For value of sine or cosine, there was no tangent, but there was a ratio of sine and cosine, what we nowadays call tan. And all the reciprocals at cosine and sec were there, and cot were there, but these names were not there. Only ja and koja was there. Ja means sine, and koja or kodija was cosine. And with these two, we can make all the six trigonometric ratios. The direct ratio is tangent, we know. The reciprocal is called the reciprocal of ja, that is sine is cosine, cosec, and the other one is sec, we know. So all these mainly three were used with these two geometric or trigonometric functions. Mainly, his contribution is nowadays known as Gregory series, which is tan inverse. Then infinite series for the value of pi. Then it is called uh, Leibniz series. The other one is sine cosine infinite series, which is called the Newton's power series. All these he were mentioning in his books. Mainly, his book is one is the some sort of modification of Vararuchi's Chandravakya. Here it is called, first it was called Chandravakyani, then he introduced a new method and it is called Venu Aroham. Venu means bamboo. So in bamboo, we climb like this alternatively. So with this method of alternative approach, even in the daytime, we can find out the position of any planet in the celestial sphere without calculating from moon. So the moon's position was already made with these 248 Chandravakyas. It was there, and it is called Venu Aroha. We have made other books also. Chandravakyani is there. Spuda Chandrapti is a much more corrected version of this Venaroha, and many of these books or manuscripts are not available, but his disciples has mentioned many of the slogas, quotings of Madhava Uktam, like that. Madhava Uktam means like Madhava told. So we find all these many of the series from the later mathematicians. And his direct disciple was Vadasheri Parameswaran. He belonged to Kasanda Malappuram district and very near to Tirur and Alathur village. His family name was Vadasheri Illam. He is a Brahmin. And his birth was in 1380, and much more details is not available, but He also, like Haridatta and all these things, he started observing the uh, eclipse, mainly 55 years. He continuously observed the different eclipses, as moon as well as sun, and he find out the difference. In a way, that in that medieval period, there was a belief that those who are going out when there is a eclipse, he should be outcasted. In a way, he was outcasted. He was always in the river bed of Nila, that is Bharatapura, and observing this in the night. And he introduced a new manual how to calculate the difference and correct the position. It is called Drik Ganidam. Drik means looking or observing. Observing the Ganida based on the observation. With a naked eyes, he observed all these things and he find out how to calculate all these things. In this way, he gave correction to all these sine series, tangent series, all these things. And one of his unique contribution is that in circle, and he find out a formula for finding out the radius of the circumcircle of a quadrilateral. This was later found out in Europe by 1782 by Lulier, a mathematician. But 350 years back, he has mentioned how to find out this uh, circum radius of a circle that is described in a quadrilateral. Many books he had in his credit, more than 12 books. Many are in manuscript form, many are the rectification of his own earlier. And Goladipika is one of the famous book other than his Dragganida. Now I am um, making very brief the remaining people which we know little about all these things. Now comes the Nilakanda Somayaji. Nilakanda Somayaji was popularly known as Kelanur Chomadiri, which is a colloquial style of Nilakanda Somayaji's name. He belonged to Kelanur family, Kerala Nellur family. Kerala Nalla Uru, that is the expansion. Nalla Uru means good village of Kerala. In very near to Trichur, there is a Kerala Ishwarapuram, Kerala Ishwarapuram. From there, in the ancient concept, Kerala is from Kanyakumari to Gokarna. Parashurama made Kerala from Gokarna to Kanyakumari. The midpoint is this place. So there is a temple called Keraladishwarapuram. Nowadays it is in a short form abbreviation. It is KR Puram. So there was a family, Kerala Nellur family. He belonged to this Kerala Nellur family. That family is that tradition is not there. So that family was um, absorbed by another family in the meantime. It is with Etamana Illam, it is called. And he has given a different type of man. He has given his date of birth, his family, his father, mother, brothers, his wife. All these things he has elaborately told in different, especially on the Aryabhatiya Bhashya. And in 1444 he took birth, and he has made this Tandra Sangraham. Tandra Sangraham is considered as the authentic book of modern mathematics. And there are even in these, after that he has written a lot of books like Chandrapti, Aryabhatiya Bhashya, I told you, and he was a centurion. He lived 101 years. That is in 1550 45. He took his last breath, and in 1500 he completed his this uh, book that is called Tantra Sangraham. Then comes another person, Shankara Warrior. Shankara Warrior is he belongs to present Palakkad district near Ottapalam in Trikkadiri Gramam. He was a assistant in a temple. It is called in Kerala Kazhagam, that who cleans the temple premises, making mala, this haram for the deity and preparation for the puja things. He was an assistant. It is called the Kazhagam, and he does not belong to Brahmana community. Even though with his talent in mathematics and astronomy, he was encouraged by others. He wrote a small Vivarana book or Vyakhyana for Tantra Sangraha, and then he started a big commentary on Bhaskaracharya's Lilavadi that he couldn't complete. Thereafter, that book was completed by another mathematician and Vedic scholar called Mahishamankalam Narayanan. And this book is called Kriya Karmakari, which is a very, very authentic book on Bhaskaracharya and Indian mathematics system. Then comes Deva. Deva is identified as the man who wrote the first book in mathematics, calculus, on the topic of calculus, that too in a vernacular language, that is Malayalam. It is called Yukti Bhasha. Ganita Yukti Bhasha was the full name. Actually, that was a translation or commentary on Tantra Sangraham with his own experiences. Till Yukti Bhasha, the style of Indian mathematic books were they will present only the results. How it came, it is called Upapatti. That is the way of coming to the conclusion, the methods, the proof. We can say the proof. It was not anywhere in the books, even in Aryabhatta's, anywhere. But in this Yukti Bhasha, Deva introduced this way of giving proof to every statement. For every result, he gave a proof. And he had two books. One is in Gadya, that is in prose, that is this Ganita Yukta Bhashya is in Malayalam prose, and another book here. And the same Yukti Bhasha he made it in Sanskrit also, because in that time Sanskrit is considered as the language of the learned persons. So he made it for them also, and for popularizing the Indian knowledge system, he made it in Malayalam also. Basically, he wrote in Malayalam, then made a Sanskrit version. And there was a misconception that this Yukti Bhasha was compiled by one Brahmadattan in 1715, because in 1715 a Brahmadattan was re scripted this original in a palm leaf. That original palm leaf was first found out. So they told in that time, especially in Kerala Sahitya Charitram of Pullur, which is a gazetteer of Indian Kerala traditional knowledge system. There he mentioned this Yukti Bhasha was written by this Brahmadattan in 1750. And thereafter, only in a later period, only the original script of um, Yukti Bhasha was revealed, and now that difference is nowhere. And Drikkaranam was another book, and Drikkaranam is a commentary of manual book. This Karana means manual. So this was a Karana book or manual, how to calculate all these things based on Vadasheri Paramareshwara's Ganidam. And with the short of time, I am mentioning only two persons in the remaining time. One is Pudumana Somayaji. He may be a recent. He lived in 1662 for 1740, and in 1732 he compiled his book called Karana Paddhati. This Karana Paddhati is a very famous book and of taking all these previous experience of right from Varadoji to Jeshtadeva. And by name itself, he is Somayaji. Somayaji means he was the Adhikari of Somayagas. And he was not an expert in mathematics only. He was on this Darshana, Shastras, and Vaidika, Tantra. In all the areas, he had written many books. And Jadaga Desha Margam, Nyaya Ratnam, Smartha Payaschitam, Panchabodham, all these are his books. And then comes Achyuta Pishareddy. Achyuta Pishareddy was in 16th and 17th century. His actually he rectified or he simplified all the previous books because he was conducting a gurukula in his own on home. He was also a non-Brahmin and he was a assistant in the Kandur Mahadeva Kshetra, very near to this temple. His ancestral house was there till 20 years back. But now that family is no more, and the land was also so many other people they took, and the urbanization and the new structures came there. But the place we know it is still called as Pishara place. That is, Pisharam is called their family because they belong to Pishara caste, Pisharadi caste. And he had all the books in very simple form because he was a teacher for the preliminary people for Vyakarana and Jyotisha, Ganita and Kavya, all these things. The famous Melpattur Narayana Bhattadirim was a disciple of Achyuta Pisharedi and he married his daughter also. In that both way they were connected, and in his main contribution that was the correct calculation of modern solar system. Now it is credited to Brome of Europe, but in 1593 itself he made these orbits of different uh, planets in the solar system, and in that way that book which he is dealing this is called Rashi Gola Spuda Nidhi. Spuda Nidhi means the correct place. The last man is Shankaravarman. He is considered as the last man of this Kerala traditional mathematics series. He was the younger brother of Kadathana to Raja, and he was uh, commonly known as Appu Tamburan. And during that time, the Mysore aggression was there in Malabar, and their family was migrated to Travancore, and he was taken asylum in Travancore with Swati Tirunal, and there he started his all this mathematical Jyotisha prediction. He correctly predicted Swati Tirunal's death as well as his own death. It is very interesting to note that it was very recent thing that both was happened with the correct timing, and he was not a um, innovator in the field of mathematics, but his prediction was very precious and correct, and he compiled all the mathematical and astronomical findings of Kerala School or Indian School of Mathematics and made a book. It is called Sad Ratna Mala, and he offered this Sad Ratna Mala. Mala means harness with Sadratnas, good precious stones, and given as a precious mala to his family deity, that is Loganarkav Bhagavati, and it is called Satratna Mala. Actually, he started popularizing Indian or Kerala mathematics through his inspiration, W.C. Vish. He was a civil servant in northern Malabar, very near to this Kadathanat. He learned all these mathematics. He wandered all around Kerala and made a paper on Kerala mathematics, not Kerala mathematics. It was the Hindu Ganida, Hindu Courtyard he called how the pi is dealt in Hindu mathematics, right from Aryabhatta to Shankara Varman. And this was presented in 1832 in the Irish Conference of Asian Royal Society of Asiatic Society, Royal Asiatic Society, and it was published in their proceedings in 1835. But the Europeans were not ready to accept all these things. They denied all these things. Even before W.C. Vish, another person has presented this similar thing on mathematics in Brahmanic literature in European before European scholars, but both were denied, not recognized because of this European supremacy. They believed that these Indians, bloody Indians, were very superstitious people. So there it have a put an end. After 100 years, during the freedom movement, by the inspiration of Swami Vivekananda, Vibhuti Bhushan Dutt, like people came to research in mathematics, Indian mathematics. He produced the big, marvelous volume, The History of Hindu Mathematics, in just after 100 years in 1935. That was a lecture in Banaras University from 1927 onwards, and that was published by Motilal Banari Das in 1935. Then everything is with us. Thank you. Thank you all. If you have any small queries, you can put that.
As you mentioned, Madhav Acharya ji and the Sangamagrama School of Mathematics, his teachings, as you said, the Europeans were not ready to accept. But strangely, and not it's unsurprisingly, we all know that how they, stole our in ancient knowledges. The Jesuit priests took Madhavacharyaji's teachings and went to Europe, and they kind of stole and started teaching that there, and they made us devoid of our ancient traditions. So I just wanted to have ask you a small question. Like, our ancient acharyas and rishis, when they taught mathematics, it was in a very connected way. Like Leelavati of Bhaskaracharya ji, when he taught mathematics to his daughter, it was such a beautiful way of teaching that everybody felt connected. It's like a story. So that's what I wanted to say, that when we learn mathematics today in our modern schools, supposedly modern schools, it is a very disconnected thing. All the concepts are disconnected and they're just thrown at you. And we read Euclid and we read Pythagoras, we read all these European thinkers and these ancient Greek thinkers, but we don't read anything about our great sages and rishis.
The way of teaching mathematics should be changed. It should be connected with the real situations. Um, for example, the fraction. It is very simple. Where the fraction is used, it used in many field like preparing many compounds, maybe rasayanas, that means aushadas, or some places. Or this trigonometry, all these were dealt in spherical geometry, in astronomical calculations. And this was used for construction of big constructions like gopuras, all these things. So when this is dealt in the real situation and the life situation, then mathematics will be more meaningful, it will be more enjoyable, and the students will feel a need. Now they are not feeling a need. What is the need of trigonometry, sine and cos for a student? Now we made everything compulsory. Only those who are going for engineering and all these areas, they need these things. So we should take back the system and the way of teaching with modern concept and requirements in the coming days. The teachers has to do, and those who are working in the preparing textbooks, they have to think of all these points. Now, I think in the proposed NAP, it is told even the mathematics, there should be a differential approach, and uh, it should be kept in real life situation.
I would just like to know what exactly was the era before this Katapayadi system of numerals came into picture. So I'm given to understand that before I think in the BC era we had we were building yagneshalas which would actually require precise trigonometric calculations and so on. So if sine and cosine were discovered later, so how was this done? And then as an addition to this particular question, how exactly, what do you say? I mean, before the numerals were represented by symbols, if they were known merely by different words, how exactly that would have kind of impacted the development of mathematics as a subject itself, right? The calculations and all those things should have been impacted. So can you just throw us an insight or an idea about how exactly mathematics progressed as a discipline before numerals were represented as symbols?
Sankhya was already spelled out even in the Rig Veda, Egam, Desham, Shadam, Sahasram, up to in the modern representation 10 raised to 57. That was a big number. For every uh, number of powers of 10, it was powers of 10, that is decimal system. It was named, but up to Pararda, Kodi Pararda, that was common, which was in usual forms, very popular, and in all bigger numbers, which was very less in usage. In different books, different names are given for the same number. Maybe Parartha may represent in some test 10 raised to 17, for example. In somewhere it may be 10 raised to 20 something. So up to 10 raised to 12 like number, these names were in common. So before numerals there was Sankhya. Sankhya means not digit, but the number was there. Digit was introduced as a Libby. Different Libby's was there. For example, in Devanagari Libby, even before Devanagari Libby, for numerals, Bhashyami script were there. So many script were there. So different type of script were evolved, and the modern 10 digits what we use today is basically Hindu scripts. And these Hindu script they moved from India to Arabs because Arab were the traders with this trading community. It went to Arabia, and from Arabia, along with this pepper and cardamom, all these spices, they took Indian numerals also, especially from this long western seashore, that is from Gujarat to Kanyakumari. There were so many ports, and mainly all these mathematicians, whether it is from Ujjain to this Kanyakumari, all crossed this area mainly, and the mathematics was taken with the Arabs. Arabs does not mean Muslims. That time Arab was a very rich cultured area, and Aryabhatiya was translated to Arabi in the very earlier time itself. Then Bhaskaracharyas, everything was translated to Arabia, and from there, from Baghdad, that was moved to Peru and some Greek university, that area. And they told this as Arabic numerals. Arabic told these Hindu numerals, then the European called these Arabic numerals. Thereafter, in a few years back, when Indians started claiming uh, our contributions, they started telling Indo-Arabic numerals. But it is not Indo-Arabic numerals; it is purely Hindu numerals. But we are telling these numerals, that is what we are writing 1, 2, 3, 9, and 0. They are European. It is not European. It is the font is continuously changing by the introduction of computer fonts. How these numbers are changing, you know. But the evaluation of these numerals, you can see from many script how it changed and evolved like this. So there was number system was earlier, the numerals, the symbol for this system was introduced later, maybe later. It was writing because that is why they used Katabayadi, Buddha Sangha, all these things because they were writing their date of birth, their all these things, length, everything was writing in using some words, some. Um, so they introduced Buddha Sangha. Another one is Paral Sangha Sambradayam, Paral Sangha system. Then Kadabayadi. Many systems were there.
Thank you for a very informative lecture. One of the things I would request you is to prepare a list of sources and original primary sources and where they are available, because in Kerala, it has been responsible for rejuvenating much of for history, not only mathematical history but also other aspects of history. So it would be very good if you can provide us with a slide of all these actual archives and so on and so forth. And secondly, I want to know, in terms of it's been said so many times that Kerala mathematicians actually formulated calculus, but at the ground level, how does it compare with the calculus of Newton and Leibniz? And maybe we have lost the tradition somewhere, because of which the European mathematics is taken over. What are your thoughts on this?
A bibliography is already prepared by K.V. Sharma and it is published by government authorities also. But it was in 72, before 15 years back around. So we want to inspire the young researchers to find out the materials, because many old families, especially where these palm leaves are kept, temples, all are undergone renovation, demolition, everything has gone unknowingly because of this urbanization, modernization. Okay, whatever available, it should be identified and collected and preserved. Many such projects are going on, and many are digitalizing all these things. Many projects are going on in many places, but much fund and interested people are not coming. And the other thing, just scanning these palm leaves is easy, anybody can do, but reading that and understanding that is a big issue, because the present generation, even my own generation, does not know. Those who knows modern mathematics, modern science, they does not know Sanskrit. And those who studied Sanskrit, they took Sanskrit as a, from their pre-degree level or +2 level, they moved to arts subjects. So arts and science, they made two separate watertight compartments. So it is very difficult. That is why the central government in the new education policy, it told there should not be any silos or this type of demarcation. So liberal arts or science and arts, everything should be clubbed. A student can take both science and Sanskrit. So we want to guide, inspire the young students to take both science, modern science and mathematics, like Swamiji told. We want to learn the modern science, but we should not leave our traditional wisdom. The traditional wisdom is in our languages, maybe mostly in Sanskrit, and there are so many in our own local languages. So this language, Indian languages and modern science, if we take in our own this group, how many science background people have their higher studies in languages? Nobody may be having. So this, we have to plan like this. And third question was on calculus. What is calculus? Calculus is, in Indian languages, in Sanskrit it is kalana ganidam. Kalana means adding many things together and subtracting. So this is calculus. Or fixing the point of a moving thing with a referral point. So all these things, because all this planetary motion was happening always, so they fix a temporary framework and fix the place, and then they calculate how the other, their line of reference is moving. So this comes the basis of calculus. Calculus is nothing but change in the rate of change. In simple ways, it is rate of change. So not only from Kerala mathematician, from Bhaskara, we can see this basics of calculus, and it flourished in the 14th and 16th century, and it appeared in the European scientific sphere in the 17th, 18th, 19th century. 17th, 18th century means the Indians has gone down and the Europeans has come up, like Newton, Leibniz, all these people. And in the 20th century, in the beginning itself, none other than Albert Einstein told, no, we owe a lot to Indians because they taught us to count, without which we can't have any worthful scientific discoveries. So it was recognized by many scholars. If Einstein has recognized this, the scientists, the such great persons are recognized. But we don't know, Indians don't know that we have done like, even we don't know that Einstein has stated like this. So it is our duty in the schools and colleges. We want to make all this in our content. We are trying for that.
One other issue in terms of mathematical education is that I want to know your views on the role of language when you teach mathematics, especially at the lower levels.
It should be
Because
their mother tongue, local language.
but the real question arises as to whether students of this generation know their mother tongue better or they actually know English better. I don't know. Maybe I'm influenced by the urban climate, but
Only less than 10% of Indian populations know something English. Only 3% is mastered in English, and more than 90% are in their language, local languages. Those who are getting higher education only mastering in English. So anybody can master both in English and a base in their concept, because mathematics is a reasoning language. So reasoning will be in their own, in which language they dream, in which language they can express things. So the basics should be in their language. Some technical terms we can take the common names. We need not tell ja and koja nowadays. We can, the sign is came from ja only. So we want to put a side column, a small note, how the sign, the term sign came. It came from ja. What is ja? Cosine is from koja or kodija. It is, the root is in our own language. When they find out, oh, this is our own, then they will be more inspired. And all these many things. 1, 2, 3 also. They are from Indian origin. The sound itself is from our origin. So some terms may be the modern terms. If so, that we have to accept. Calculus we know, but there is kalanam. Kalanam means making, arranging small things.
So, Mr. Vinod, thank you very much for this interesting talk, because your talk was not purely on mathematics, but is also history of mathematics. So I was quite interested in this topic, and especially about Mr. Madhava of Irinjalakuda, etc. But
And Shankara Warrior is very near to your place, Trikedi.
very close from Trikedi. Yes, yes. So it was very interesting to listen to your talk. Yeah, brings me a lot of memories. And even the great Guru Achyuta Pisharudi, my father always used to talk about him and how Pisharudi was the guru of Bhattacharya. My father is also a Pisharudi, so I have great pride in that. But I've been listening to a few Sangam talks, many Sangam talks also. What I want to know is, we always talk about how India contributed to the world in terms of science, mathematics, etc., and how the Arabs had been a sort of channel. So even if the information went from India to Europe, even if the credit many times went to Arabs, it's still okay. We all know that there has been an information flow, a knowledge flow from India to the Europe. But there must have been also some reverse flow, some flow from either the Middle East or the Europe to India, because the information flow cannot be one way. For example, things like the zodiac, the 12 signs of zodiac, it did not come from India. It came from the other side.
Great.
Right or not?
Yeah.
So So we cannot say if it is Jyotish or if it is something about astronomy. I think we must have gained a lot of knowledge from either Sumeria or Mesopotamia, etc. And the Arab must have brought that knowledge to us. Can you tell us something about this reverse flow? How much we have gained from the other side?
Yes, yes. Very interesting angle that you are presenting. And India's concept or knowledge is that Ano Badra Kradavo Endu Vishwadara. Wherever the noble thoughts are there, let it come close to ourselves. We are ready to accept it. So there was always a giving and taking process. So that is why when we gave something, there was even in Arabia, that is Baghdad was a center of learning, observation, and all these things, center of knowledge. And Egypt was like that, Peru was like that. So many ancient civilization was there, and there was mutual taking and giving of knowledge and systems. And that is why we know this numerical decimal numerical system that traveled across the world, that is originated from India. Likewise, many, as you told, the zodiac, this Rashi Gola, the concept was came from outside also, but in India there was continuous correction in that. There was no, whenever they came to a difficulty or something error in this concept or in these calculations, they tried to correct it. That is why the solar system, the concept of solar system arrived when it was first, it was Bhukendrada, Earth was in the center. Then the concept developed, all the planets were revolving around sun. That system was revolving around the earth. That concept developed. And even Achyuta Pisharidis time also, this Helisic, Hellerian, something it is called in English, I think, it was developed. And it evolved to that no, this Earth is also a planet like that. So it took a long time, but every new model was developed on the findings, observatory findings of the difference of observation and calculation. So when there is a difference in calculation, it should be because of the error in the concept. From there, the concept was remodeled. So there was equally taking and giving. But if we take how much we gave, it was not recognized in the modern era, especially in the 18th and 19th century Europe. They have declared that whatever new knowledge they got, especially from a place where they were ruling, they should not declare their source. Such a um, guidance or direction was given to even the Jesuit priest and all these things. So they collected all these things, and they were not even their letters. They should not mention it. It was clearly mentioned in the letters even to these um, Jesuits, and some other documents came during. I will tell the year also. I think in 15th, 16th century, when 100 Jesuits were sent to India. Out of these 120 were learned in mathematics. So in different areas they were mastered from European universities like Peru or some ancient universities were there, and they were sent to India. And their civil servants were trained to how to communicate with Indian society, and that is why people like CHV, WC Vish, all these came here. They were given a post, maybe in court or maybe in revenue, maybe in some other. Their second work was to see mainly three things. One is in the Indian science system, second Indian education system, and third India's governing law and governance. Mainly all these systems they were studying. So there are so many documents on others everywhere. The outsiders, mainly Arabs, Greeks, contribution was there.
Till the late medieval period or the early modern period, till then, there was not much emphasis on deriving proofs of any say theorem or an axiom. So I would like to actually understand how exactly those theorems and axioms were formulated in the first place. So my limited understanding is, because I don't have much knowledge of mathematics, frankly speaking. But then as per my limited understanding, you make an observation, maybe in nature or anywhere else, or you observe something, and then based on that, you go ahead and derive something. So if if the concept of proof came much later, how exactly were derivations happening? How exactly were theorems and axioms formulated? Is it something magical, like apparently magical today, like we encountered from the life of Srinivasa Ramanujan, or how exactly did it go through?
Srinivasa Ramanujan is a modern typical model, because in the end point what they gave to the coming generation was their end results. So they might have undergone many calculations, revisions, then again error correction, all these things. I told Vadasheri Parameshwaran, he spent 55 years as an outcasted man, because he left his home and he was always wandering in the riverbed and lying there itself and observing the planets and calculating. In night time, they will observe the planets, they will note down, then they will calculate. All these calculation may be in mental calculation, some other type of calculation. Padi Ganidam was there. Even now, the Kerala South Indian astronomers, they use with this Padi, some pearls. They like our Chinese, this abacus. Some calculation methods were there that we don't know. So all these calculation they find out in a different may not be in paper and using paper and pen nowadays. So at the end point, what they have received, and after many repeated uh, rectification and again, whether it is correct, true or false, they corrected and then put the as a final these things. That is, this is not like writing a poem. So, in many books, if you go, when it started from their Kali Dina Sangya, what they mentioned, and when they ended, we can see this. And again, there is a second book. For example, Madhavas Puda Chandrapti is the book. Then he revised it. Nowadays, it is the second revised edition. So he revised it like 2, 3 times. It is revised in their own lifespan. And many in the earlier stage, if we see, after Varuji, Aryabhata comes after 100 years. And Aryabhatta is much. Two books he has written. One is Aryabhatiya Ratraya Siddhanta. It is not available nowadays, and he himself corrected it. In the North India, this Aryabhatiya Ratri Siddhanta is following, and Aryabhatiya is following in the South. They are telling. So different schools are there, and even in India, it is a very vast area. The observation at different places will yield different result also. Nowadays, we know where the eclipse is full, a ring moon, where it will be seen. Like that, we know nowadays where it is full and partial, all these things. In the same way, it was like that only. So, this type of observation that we have to do, and this proof, we have to identify in the first beginning itself. They are giving all the method of calculation in all these books. The first and second chapters may be the methods of calculation, how they can find out all these things. So thereafter they will introduce their new topics.
Yes, I just want to know what kind of calculating devices like abacus, slide rules, and other things have been found, in India in general and in Kerala in particular. What do we know about them?
In Kerala, they use the kabadi, that is small shells, or some pearls. It was there. Mainly their mind calculation is the highest equipments they had. The methods that we are using now, Vedic mathematics, all these things are high speed mental calculation. They can calculate mentally many things. And the remaining they will make with this type of calculation.